Good morning, Algebra 2, and welcome to class. Today we are looking at section 11.3 in our probability chapter. We will be focusing on events that are either independent or dependent. The first thing that they want you to focus on are independent events. And it says events are independent events if the occurrence of one event does not affect the probability of the other. So some examples are if you are flipping a coin. Okay, so if I flip a coin, the chance of getting heads would be 1 out of 2. Because there's one head on a coin, the sample space for a coin, you have two options, heads or tails. So let's say I flip that coin and I get heads. Okay, so I have a 1 out of 2 chance. Then I go to pick it up again. The probability does not change. If I want to get heads, there's still one head on the coin. The denominator is the sample space. When you flip a coin, it's still heads or tails. So you can do that event any amount of times, and if you're trying to get heads on a coin, it's going to be 1/2. Other examples would be if you roll a number cube. Just because you roll a 3 the first time, when you go to roll a number cube again, it doesn't mean you have a higher chance of getting a 3 because you rolled one previously. Your chance would still be 1 out of 6 because there's 1 3 on that standard number cube out of the 6 sides. When you are finding probability of doing independent events, you take each probability separately and they're going to have us multiply those. So we're going to look at a few examples just to make sure we've got it. Okay, the first one I already have worked out just to save us a little bit of time. It says we have a 6-sided cube and it's labeled with the numbers 1, 2, 2, 3, 3, 3. So it's not a standard number cube. We have 1, 1 on the cube, 2 2s, and 3 3s. Then they are different colors on the sides. 4 of the sides are red, 1 side is white, and 1 side is yellow. They want us to find the probability. So this notation here, this means find the probability of rolling a 2. Then you pick it up and you roll a 2 again. So we are looking at 2 separate probabilities here. So we have to think of this. If I look, there are 6 sides on the number cube. The probability of getting a 2 would be 2 out of 6 because there are 2 2s on the number cube that contains 6 sides. Then you pick it up. You want to roll a 2 again. There are 6 sides on the number cube. Of those 6 numbers, 2 of them are 2s. I can reduce both fractions. 2 out of 6 can be reduced down to 1/3. They told us in order to find the probability, we want to multiply those fractions. So top times top, 1 times 1 is 1, 3 times 3 is 9. There's my ratio. We want to give our probability as a ratio, a decimal, and a percentage. 1 divided by 9 is 0.11. Move that decimal over, and we have 11%. So here is another one. Same cube, okay? It says tossing red, then white, then yellow. So you're doing the same thing. You pick it up. What's the chance of getting a red? Then you pick up the cube again. What's the chance of rolling where you have the white side facing? Pick it up. Then you roll it again. What's the chance of yellow? So notice here, we are actually dealing with 3 different fractions. Again, the number cube has 6 sides. How many of them are red? Well, it says 4 sides are colored red. So that's 4 out of 6. Now you pick it up. The cube still has 6 sides. When you rolled it, a side didn't just fly away. There's still 6 sides. What's the chance of getting white? 1 of the sides is white on that number cube. Then you pick it up. Again, you still have 6 sides on the number cube. The chance of getting yellow. 1 side is yellow. Now here you could just multiply top times top times top, bottom times bottom times bottom, and go ahead that way and then reduce at the end. I like to reduce before I multiply them. So here I notice, okay, I can reduce that down to 2/3 times 1/6 times 1/6. Again, if you want to just wait and reduce at the end, totally fine, okay? 2 times 1 is 2. 3 times 6 is 108. So even though I did reduce, notice I can still reduce further. So you always want to look and make sure that your final answer is in simplest form. 2/108, I can reduce that to 1/54. So there's your ratio. To turn your ratio into a decimal, go ahead and divide. 1 divided by 54 is 0.02 if I round it to 2 places. 0.02 is 2%. So on that particular number cube, there is a 2% chance you're going to roll a red, then you're going to roll a white, then you're going to roll a yellow in that order. Okay, here's a couple more examples just because I'm not here to see your faces and make sure you've got it. So we'll do a bunch, okay? This says the chance of rolling a 6 on a single die, picking it up and rolling a 6 again. So on a standard number cube, there are 6 sides. The numbers are 1, 2, 3, 4, 5, and 6. So if I want to know the chance of getting a 6, there is 1 6 out of the 6 sides. I pick it up. There are still 6 sides on the number cube. Okay, the denominator doesn't change. Independent event. How many 6s are there? There's still 1. So top times top is 1. Bottom times bottom is 36. 1 divided by 36, 0.03. So there is a 3% chance that if you pick up a standard number cube, you roll a 6, you pick it up, that you'll roll a 6 again. So not a very big chance. Okay, here's one more looking like this. It says tossing heads, then heads again, and then tails. So you're going to pick up a coin. They want to know what's the chance of getting heads. Pick it up, flip it again, get heads again, flip it up, and then get tails. So the chance of getting heads is 1/2 because there's 1 head out of the 2 sides of the coin. The chance of getting heads again is 1/2. The chance of getting tails is also 1/2. Top times top times top is 1. Bottom times bottom times bottom is 8. 2 times 2 times 2. Now I'm going to go ahead. There's my ratio. Turn it into a decimal. It's 0.125. So if I'm going to continue with my pattern of rounding to the 100th, I can go to 0.13. So there would be a 13% chance of flipping a coin, getting heads, then tails in that particular order.